I'm Andrew Bowie, and I'm doing my legacy project on stoichiometry because I myself used to have trouble on stoichiometry and want to help others learn it better. This video will provide a basic introduction to stoichiometry and some of its applications in chemistry. So what even is stoichiometry? It's a section in chemistry that involves calculating different quantities in a chemical reaction by comparing the reactants and products. It typically involves mole ratios, and you must use a balanced equation for stoichiometry to work. Pictured below is the mole highway. It goes from mass to moles, moles to moles, moles to mass. This will be really important in the example problems we're going to be doing. This video will cover mole and mass calculations, limiting and excess reactants, and percent composition. Let's take a look at some examples. This first problem here wants us to determine the number of moles and mass of chlorine required to react with 10 grams of sodium metal to produce sodium chloride. So the first thing to do in a stoichiometry problem like this is to write out that balanced chemical equation on the side. There it is. The next thing you need to do is divide the 10 grams of sodium by 23, which is the molar mass of sodium, and then multiply by 1/2 to find the moles of chlorine. Like that mole highway said, mass to moles, moles to moles. So there's that calculation down below, and you should get 0.217 moles of chlorine. Now, it's the easy part. You just multiply 0.217 moles of chlorine by the molar mass of chlorine, and you should get 15.4 grams of chlorine. In this example, we're investigating a white powder found at a crime scene, and we're given different measurements of carbon dioxide, water, and nitrogen, and we're trying to find out if the substance is actually cocaine or not. And the formula for cocaine is given on the right. So the first thing we need to do is find the mass of hydrogen and carbon in water and carbon dioxide respectively. So what we need to do is multiply the given amount of water by 2/18, which is 1/9, because only 1/9 of the mass of water is actually going to be hydrogen. So you do that, and then you get 2.218 milligrams of hydrogen. The next thing you need to do is do the same thing for carbon, but this time multiply it by 12/44, because only 12 grams of carbon dioxide is actually carbon, while the rest is oxygen. So you do that, and you get 21.54 milligrams of carbon. The next thing you need to do is find the mass of nitrogen in the sample. So what you do is multiply 0.0462, which is just 4.62% as a decimal, times 32, and you get 1.478 milligrams of nitrogen. The last thing you need to do is subtract all three of these values from 32 to find the missing mass. So then you get 6.764 milligrams of oxygen is in the sample. You know it's oxygen because in order for it to be cocaine, look at the top right, there has to be oxygen in the sample. Next, you need to divide all of the mass values we got on the previous page for the elements by their respective molar masses. So you do that, and you get these. Make sure to keep the units consistent. So if you're using milligrams, keep using milligrams. Now notice in the original formula for cocaine, nitrogen only has a subscript of 1, which means there's, for example, 17 times more carbon than nitrogen in cocaine and 21 times more hydrogen. So what you need to do is divide all of these mole values by the moles of nitrogen, which happens to be 0.106. So you do that, and you find out that the value for carbon is 17, the value for hydrogen is 21, the value for nitrogen is 1, and the value for oxygen is 4, which means yes, this sample is cocaine. So now hopefully you've learned more about basic stoichiometry topics such as the mole highway, limiting and excess reactants, and percent composition. Thank you for watching and have a good day.